In the world of object-oriented programming, inheritance is often sold as the ultimate tool for code reuse. It allows you to build complex systems by stacking layers of logic on top of one another. But there is a catch, a significant catch. When you look at the two most dominant enterprise languages in the modern era, Java and C#.NET, you will find they share a specific limitation. Neither of them supports multiple inheritance of classes. If you have ever tried to extend two different parent classes simultaneously, you will find the compiler rejecting your code immediately. This is not an oversight. It is a deliberate design choice made to protect the stability of large-scale software systems. So why do they restrict this capability? And more importantly, how do professional developers compensate for it in production environments? To understand the restriction, you must understand the problem it avoids. This is commonly known as the diamond problem. Imagine you have a base class called vehicle. You have two subclasses, car and boat. Now imagine a third class, amphibious vehicle, that inherits from both car and boat. If both car and boat define a method called startEngine, and amphibious vehicle inherits from both, which version of startEngine does the amphibious vehicle use? Is it the one from the car, the one from the boat, or does it crash? This ambiguity creates a maintenance nightmare. In a large enterprise application, knowing exactly which method is executing at any given time is crucial for debugging and static analysis. By forbidding multiple class inheritance, Java and C#.NET eliminate this ambiguity entirely. The type system becomes predictable, and the cognitive load on the developer is significantly reduced. So if you cannot inherit from multiple classes, how do you achieve the same flexibility? The primary mechanism is the interface. Think of an interface not as a class, but as a contract. It defines a set of behaviors that a class promises to implement. A class can implement as many interfaces as it needs. This allows a single object to wear many hats. A class can be a serializable, a comparable, and a clonable all at once. This solves the structural requirement without the semantic ambiguity of the diamond problem. However, interfaces used to be purely abstract. They defined what a class could do, but not how it did it. This meant that if you wanted to share implementation logic across multiple classes, you were forced to use abstract classes, which brought you back to the single inheritance constraint. This is where the modern evolution of these languages becomes critical for production-grade architecture. Both Java and C#.NET have introduced features to bridge the functionality gap. In Java, starting with version 8, they introduced default methods. This allows an interface to include a method body. You can now provide a default implementation for a method within the interface itself. If a class implements the interface, it inherits that implementation unless it chooses to override it. This brings the power of code reuse to the interface model without violating the single inheritance rule. C#.NET followed a similar path with default interface methods. The implementation details differ slightly between the two languages, but the architectural goal is identical. They allow for a form of mixin behavior where shared code can exist within a contract without forcing a rigid class hierarchy. Yet, the most robust pattern for solving this problem remains composition over inheritance. This is a fundamental principle of software design. Instead of building a hierarchy where a class is a type of another class, you build a system where a class contains an instance of another class. Think of it as building a car using a chassis, an engine, and a transmission. You do not inherit from the engine. You compose the engine into the car. In Java and C#.NET, this is often achieved through dependency injection and private fields. A class holds a reference to an object that provides the behavior. This is far more flexible than inheritance. You can change the behavior at runtime by swapping out the composition. You can test individual components in isolation. It decouples the logic so that changes in one area do not ripple unpredictably through the entire system. C#.NET has taken this a step further with the introduction of records. Records are a specialized type of data carrier designed to hold immutable data. They simplify the boilerplate code required for value-based equality and string representation. When combined with interface composition, records allow developers to define data structures that can also implement behaviors. This is particularly useful in functional programming paradigms that are increasingly common in .NET applications. You can have a data record that implements a specific interface, allowing it to participate in polymorphic behavior without the weight of a full class inheritance chain. This combination of records and interfaces creates a lightweight, immutable architecture that is highly resistant to bugs related to state mutation. When you consider the broader picture, the exclusion of multiple inheritance is a trade-off. You lose the ability to express complex taxonomic relationships directly in the type system, but you gain a system that is easier to reason about. In the context of large enterprise applications, maintainability is often more valuable than raw expressiveness. The patterns of interface composition and composition over inheritance force developers to think about relationships between objects more carefully. It prevents the creation of deep, fragile inheritance trees that are impossible to refactor. It encourages small, focused classes that do one thing well. This architectural discipline is what allows teams to scale their software development without the system collapsing under its own complexity. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.